Hey, Algebra 2, we are in Chapter 2, Section 2. And let's start with a little warm-up. Evaluate the expression when x equals -4. So I'm going to go ahead and substitute -4. Please remember, when you type into your calculator -4 squared, you're going to get the incorrect answer of -16. But if you put parentheses around it, you'll get the right answer of a positive 16, right? If 16 minus 20 is -4. Go ahead and substitute. Third power. Make sure you use parentheses when squaring or cubing or anything negative numbers. -4 to the third power. I have -64 times -3. Sorry, I'm doing math. That one is, okay. So now we have 2 times 16, which is -32 plus 10. So 192 minus 32 plus, goodness, I have equals 170. Next, this is when I think you guys are probably sitting back thinking, dang, I hope this assignment is easy as our warm-up. Yeah, it's not. The expression x squared minus 4 represents the amount of matting in square inches that is needed to mat a picture. If you know we've got a picture, you know, an awesome picture, the matting is what goes around it. And then the frame is what goes around that. Right? Okay. Our lesson in picturing. How much matting is needed if x equals 6? Well, we're just substituting. 6 times 6 is 36, minus 4 is 32 inches squared. All right, into the lesson. So recall that a monomial is a number, a variable, or a product of numbers and variables. What this means is a number like 3, a variable like x, or a product of numbers and variables like 3x. Okay, that is a monomial. A 3 is a monomial, an x is a monomial, a 3x is a monomial. A polynomial is a monomial or a sum or difference of monomials. Okay? A polynomial function is a function of the form a to the n, x to the n, a to the n minus 1, x to the n minus 1, yada, 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 a to the 0. A to the n can't equal 0. The exponents, which are the n's, are all whole numbers. And the coefficients, which are all the a's, are all real numbers. So all the n's are whole numbers, all the a's are real numbers. And for this function, a to the n is the leading coefficient. I'm going to do that in red. Well, I should do that in blue, shouldn't I? Leading coefficient. So this right here is the leading coefficient. So a to the n is the leading coefficient, where n is the degree. That's in red right there. And a to the o is the constant term. Right here. So it's the last thing, and there is no variable on the constant term. It's just a number. Okay, if all of this is new to you, please listen to it again and own it. All right? This is the building block. You have to understand it to move on. And I don't know what math you knew before Algebra 2, so I need you to understand it so you can move on. Continuing on, a polynomial function is in standard form if its terms are written in descending order of exponents from left to right. that just means that if I have 3x to the third plus 2x squared plus x plus 3, descending order, third power, second power, first power, constant. Okay, this one right here is a degree of 3 because the highest power, the highest exponent is 3, and it's my leading monomial with my leading coefficient being 3. All right, so degree 0 is just a constant. It's just an a to the 0. This would be my example. Notice there's no variables in it. A degree 1 is linear. I have a sub 1 x to the first power. Notice the sub 1 and the first power are the same numbers on purpose. And a to the 0, which is a constant. Our example is 5x to the first power and a constant. It's linear. Second degree is considered quadratic. It's a U-shaped, either happy U or sad U. I've got a sub 2 x squared, so squared and squared, a sub 1 to the first power, and my constant. An example would be 2x squared, 1x to the first power, and a constant. Okay, third power is cubic. Notice I've got 3 to the third power, 2 to the second power, 1 to the first power, and a constant. So third power, second power, first power. My constant in this case is 0. And then fourth power is quartic. Fourth, third, second, first, constant. Notice we're only showing fourth power, first power, and my constant. All right, to example 1. Decide whether the function is a polynomial function. If so, write it in standard form and state its degree, type, and leading coefficient. That chart that we just went through is pretty helpful here. So looking through here, I've got x to the fourth minus 1/4 x squared plus 3. This is a polynomial function because it satisfies the definition that we just went through. It has a degree of 4 because that's the biggest exponent. So it is quartic. And its leading coefficient is 1, because when there's nothing in front of the variable, we always know that there's a 1 there. Mathematicians are lazy. We don't want to write the 1. Decide whether the function is a polynomial function. If so, write its standard form. State its degree, type, and leading function. So we do, in fact, have a polynomial function here. I need to rewrite it because we've got a degree of 2 that has to be first. Pi x squared plus 7x minus square root of 3. Its degree, I can say yes, it's a polynomial. Its degree is 2, so it's quadratic. Its leading coefficient is pi. You cannot write 3.14 because you've rounded it, so go ahead and write pi. What else do we need? That's it. Got it. Okay. Let's see. Here we have a funny little 3x to the negative 1. So this monomial right here means that it is not a polynomial. Okay? Because our exponent is not a whole number. That monomial right there, I've got 2 to the x power. Okay, so we're not a polynomial because 2 to the x power does not have a variable base. Where that is considered the base. Okay? I mean, I could use anything there. I picked A. Normally, let's do, I don't know, W to the 4th. This is the base, and this is the exponent. Okay, so we're saying this is not a polynomial because 2 to the x does not have a variable base. Okay, that's not a variable base. And the exponent is not a whole number. It's not a number, it's a variable. All right, moving on. So we're going to evaluate by direct substitution here. This is where we just have to watch our negatives. So use direct substitution to evaluate. This is where we evaluate the function at 3, and that's how you write it. So we're saying x equals 3, so we're going to evaluate the function at 3. So 2, 3 to the 4th power minus 5, 3 to the 3rd power minus 4 plus 8. If you remember, we learned how to store 3 into our x on our graphing calculators, and then we could just type in the equation as seen, and the calculator would do all of the awesome work for us. It would spit out the correct answer just like that. If we would hit 3, and this right here is the store into x. But if you do it by hand, 3 to the 4th power, I believe, is 81. 3 to the 3rd power is 27. 2 times 81. Oh, 5 times 27. And that right here does evaluate to 23. All right, direct or guided practice. So now we're going to review. We got one of those, use direct substitutions. So here we have 13 minus 2x. This is a polynomial, but let's get it in order. That negative is in front of the 2, so it has to stay there. You can't just switch things and leave the negatives in the middle, okay? The negative sticks with the number that it's with. Here I have a degree of 1, so it's linear. And the leading coefficient is negative 2. That right there is a nope, right? We learned that. Just like the example we did. What example was that? If you look at your notes, that's example C. So example 1C had the same type 1. So not a polynomial. Here, yep, we do have a polynomial. Let's put it in order though. Minus 3x plus pi. Our degree is 2, so it's quadratic. Our leading coefficient is 6, and yes, it's a polynomial. Direct substitution. X is negative 2, so you can either store the negative 2 or just crunch some numbers, use lots of parentheses. When in doubt, add more parentheses. If you crunch all those numbers, you actually get an answer of 5. And how we'd write that, is f evaluated at -2. Here we have g evaluated at 4. 4 cubed minus 5 times 4 squared plus 6 times 4 plus 1. This all gives you a 9. I don't know why there's a little fancy curly Q in there. All right, this is the last thing we're going to do for this part of the lesson. This is called synthetic substitution. I think it's fun. Another way to evaluate a polynomial function is to use synthetic substitution. This method, shown in the next example, involves fewer operations than direct substitution. So we've got 3 steps. We're going to write down the coefficients of f of x in order of descending exponents. Write the value at which f of x is being evaluated to the left. Step 2, bring down the leading coefficient. Multiply the leading coefficient by the x value. Write the product under the second coefficient and add. This will make sense as we go through one. Then we're going to keep on multiplying and adding and multiplying and adding and multiplying and adding. I always thought this was sort of fun. Let's try one. So step 1 says write the coefficients. So first we're going to evaluate at x equals 3. We've got a 2x to the 4th, negative 5x to the 3rd. I need a 0x squared, negative 4x, and 8. And then I draw a line. Bring down the first one. We're going to go ahead and multiply the 3 and the 2. So I always multiply and write it up here. So multiply. 3 times 2 is 6, and I'm going to add. Negative 5 plus 6 is a 1. So I just did 3 times 2 is 6. Now I'm going to go 3 times 1 is 3 and add. Following me? Let's see if I can get a different color here. Now I'm going to go 3 times 3 is 9 and add. 3 times 5 is 15 and add 23. If you recognize this problem, it's the same one that we did in example 2. And we evaluated at x equals 3 and we got an answer of 23, right? So we can say that f of 3 is 23. And that's actually where we're going to stop, okay? Good work. Go ahead and try your problem set. If you need to rewatch example 3, go for it.